Mole Rocket Challenge.
Introduction. The purpose of this project is to understand Newton's laws of motion, investigate projectile motion, apply principles of aerodynamics, and analyze energy transformations. Newton's third law of motion states that for every action, there is an equal and opposite reaction, which explains how the explosion of gas from the baking soda and vinegar reaction caused the rocket to propel forward. The principles of projectile motion show the bottle rocket's trajectory when launched, which allows us to investigate the path and height the rocket will take. The principles of aerodynamics allow us to understand how the shape, size, and other factors allow the rocket to launch at such heights. The rocket goes through an energy transformation, as the energy transforms from potential energy, the compressed air in the bottle, to kinetic energy, the rocket's actual motion.
This is the definition portion. Some of these will be shortened for the sake of time. Thrust is the propulsive force of a jet or rocket engine. Gravity is the force that pulls mass to the center of the Earth. A chemical reaction is a process that leads to the chemical transformation of one set of substances to another. Oxidizers are any substance that oxidizes another, and an oxidizing agent is a substance in a chemical reaction that gains an electron from a reducing agent. Newton's third law of motion states that in nature, every action has an equal and opposite reaction. A fuel is any material that can be made to react with other substances so that it releases energy. Pressure is a physical force exerted on an object by something in contact with it. Combustion is a burning chemical reaction with a fuel and an oxidant that produces oxidized products. An excess reactant is a reactant that is not used up when the reaction is finished. And the limiting agent is one that is completely used up, limiting the amount of products formed. Stoichiometry is the relationship between qualities of reactants and products before, during, and after chemical reactions. An acid is a chemical that gives off hydrogen ions in water and forms salts by combining with certain metals. A base is any substance in a water solution that is slippery to the touch, tastes bitter, changes the color of indicators, reacts with acids to form salts, and promotes certain chemical reactions.
Background. Our bottle rocket works due to the third principle of Newton's law, which states that the pressure inside the bottle transforms from the potential energy to kinetic energy, which causes it to launch forward. This project relates to acid and bases because it shows the creation of carbon dioxide gases through a chemical reaction. Baking soda, the base in this reaction, and vinegar, the acid, react to carbon dioxide, which creates pressure and allows the bottle to propel through the air.
Acids and bases. Acids are ionic compounds with hydrogen ions as locations. They have a sour taste and their pH is less than 7. They can cause indicators to change colors and they turn litmus paper pink or red. Bases are ionic compounds that have hydroxide as their anions. They have a bitter taste and their pH is greater than 7. They are slippery and can cause indicators to change colors. The reaction. When an acid reacts with a base, it produces neutralization. Vinegar reacting with baking soda neutralizes them, building up carbon dioxide in the bottle. When the pressure is high enough, the cork pops off.
Procedures. Tape 4 pencils to the top of the bottle to be used as legs for the rocket to stand on while launching. Decorate the rocket. Add a cone, add wings, or decorate however you like. Fill the bottle halfway with vinegar. Put about 1.5 tablespoons of baking soda in the center of a square of paper towel and roll it up. Twist the ends to close the baking soda in. Place the paper towel into the bottle. Put a cork in the mouth of the bottle. Turn the bottle upside down and let it stand on its legs on a launch pad. Wait for the rocket to go up.
The materials we used for this project were vinegar, baking soda, duct tape, 2 empty 2-liter soda bottles, number 2 pencils, construction paper, a cork, and paper towels.
Here are the physical and chemical properties of vinegar and baking soda. Vinegar and baking soda. The baking soda and vinegar reaction is actually 2 separate reactions. The first reaction is an acid-base reaction. When first mixed, the hydrogen ions in the vinegar react with the sodium and bicarbonate ions in the baking soda. The result of this initial reaction is 2 new chemicals, carbonic acid and sodium acetate. The second reaction is the decomposition reaction. The carbonic acid formed as a result of the first reaction immediately begins to decompose into water and carbon dioxide gas, just like carbon dioxide bubbles in a carbonated drink. The carbon dioxide that formed as a carbonic acid decomposed rises to the top of the mixture. This creates the bubbles and foams you see when you mix baking soda and vinegar. The chemical reaction formula is NaHCO3 plus CH3COOH, which yields CH3COONA plus H2O plus CO2.
Limiting and excess reactants. The limiting agent in this experiment was the baking soda, as that was the substance that determined how much energy was produced and how high the rocket would go. In the end, the excess reactant was the vinegar, as there was some left over in the bottle as all of the baking soda dissolved. And the formula for said reaction is below.
Errors and solutions. We did not have a cork large enough to cover the opening of our bottle, so we wrapped duct tape around the cork to fit the cork without leaking. We had trouble fitting a tissue filled with baking soda within the bottle opening, so we used a funnel to fit the baking soda inside the bottle. This also allowed the reaction to be more immediate, as previously the tissue had to dissolve before the reaction would occur.